Hello everyone, I'm Mahathi Manjipudi with Global cli-MATES, and in today's Earth Science video we'll be going over a closer look at Earth's mantle. So to recap a little bit of what we've already discussed about Earth's mantle is the layer found in between Earth's crust and Earth's core. And it's the solid rock layer that actually makes up about 82% of Earth's total volume. Of course, this diagram is not to scale, but you can see that, the mantle has the most area shaded in here. Now, the mantle extends all the way down to a depth of about 2,900 kilometers. Again, showing that it makes up a majority of Earth's inner structure. Now, turning our attention to this zoomed-in version, we can start taking a look at the specific properties of Earth's mantle. So of course we have the crust here in gray, and the remaining three, orange layers there a part of the mantle. Now, how can we tell the crust apart from the mantle? Well, the reason why we can transition into a mantle is because the mantle has a different composition. The mantle is primarily composed of the rock known as peridotite, and it differs from the crust in chemical composition because peridotite is richer and contains higher concentrations of magnesium and iron. So that's the chemical composition difference between the crust and the mantle. And actually, this distinction between the crust and the mantle is known as the Moho discontinuity. And once we pass the Moho discontinuity, we get into the mantle. It's kind of like, how you have a sign at the border of a state telling you when you cross into another state. The Moho discontinuity is where we cross from the crust into the mantle. Now we can take a look at the mantle, and in the mantle we can see that there are a few layers. We can first break up the mantle into two components: the upper mantle and the lower mantle. Taking a look at the upper mantle, we can see that the upper mantle is further divided into two more sections. So these sections are known as the lithosphere and the asthenosphere. Now, the lithosphere is, it's a brittle, hard, cool rock found underneath the crust. And, the lithosphere is typically 100 to 250 kilometers wide. So we talked about how continental crust is thicker than oceanic crust. Same goes for lithosphere. Lithosphere found underneath the continents are more towards the 250 side, whereas lithosphere found underneath the oceans is more towards the 100 kilometer side. Below this brittle layer of rock, we have the asthenosphere. Now, the asthenosphere is a softer rock layer, and it's what's known as comparatively weak, right? So the asthenosphere is still, mostly solid rock, but combinations of temperature and pressure cause the asthenosphere to weaken. And over millions of years, the asthenosphere exhibits this very slow-moving plastic flow, which is important for other processes, as we'll go on in later videos. So again, the asthenosphere is not a liquid. It is still solid rock. It's just weaker than the lithosphere, which gives it these special properties of very slow flow over long periods of time. Now, together, the lithosphere and the asthenosphere are about 410 kilometers. So that's where this boundary occurs. So we have the lithosphere roughly 100 and 250 kilometers, and then we go around 200 kilometers more, we'll get to the edge of the asthenosphere. One thing to note, even though the lithosphere is brittle and the asthenosphere is weak, this transition doesn't just happen rapidly, right? We don't just have one brittle layer and then one weak layer. There is a gradual transition from the brittleness to the weak layer because the temperature starts increasing, which contributes to, the change from brittle rock to weaker rock. And then the same thing happens from the asthenosphere to what we call the mesosphere in the lower mantle. While the mesosphere is much stronger than the asthenosphere, it also exhibits a little bit of that flow, but because there's more pressure in the mesosphere, right, there's the crust, lithosphere, and asthenosphere. All of this is on top of the mesosphere. It adds to the pressure the mesosphere exhibits, so it gives it a stronger, more solid rock. But of course, this pressure change doesn't happen immediately, so there's something known as the transition zone. So this is between the asthenosphere and the mesosphere. It goes roughly to about 660 kilometers, and yeah, that's the transition from the weak asthenosphere to the mesosphere. The mesosphere also has the ability to flow, but it is much stronger than the asthenosphere. And as we mentioned earlier in the video, all of this will then extend to around 2,900 kilometers, which is where there's a transition between the mantle and the core. So that was mostly what we had today. So to recap the content we went over, the mantle makes up 82% of Earth's volume. It's the largest part of Earth's volume, and it's primarily composed of peridotite. The mantle is divided into three main layers: the brittle lithosphere, the weaker asthenosphere, and then the mesosphere, which is somewhere in between those two. Again, the mantle is all solid rock, but based on temperature and pressure, different layers can have slow flows over the course of millions of years. So that was today's video on the mantle. If you learned something and you liked it, don't forget to leave a like and subscribe to our Global cli-MATES YouTube channel, and comment down below if you have any questions or suggestions for future videos. Thank you for watching!